Hey folks, welcome out there to TNLearn's Mathline Summer School. And we are excited to be here with you this afternoon. We hope you're as excited watching and tuning in as we are to be with you. And you know what? It's great. It's summer school. It's a little more laid back. It's not a call-in day, but we're going to be back with our call-in days come August the 8th. School cranking up pretty much for everyone in East Tennessee, all over Kentucky, Middle Tennessee, all over the place that tunes in to TNLearn Mathline regularly. But you know, it's summer school. Take a piece of paper, some pencils, maybe a calculator close by. I don't know if you're going to need much of that today, but definitely get you some pencil and paper out and let's relax and do some math. All right. And today's topic, what do we got going, guys? What do we got to look at today? Let's get literal. That sounds like a song. You know, I could almost sing, let's get literal. Literal. Oh, that's another song. Let's get physical. Well, let's get literal anyway today here. And let's hear the algebra talk to us, all right? You say, what do you mean by literal? Literal means we're going to see a lot of variables floating through. We're going to look at literal equations, which are basically composed of at least two and probably more than two variables. And we're going to be solving for individual variables. And you say, Ernie, what does that do for us? Well, you know, algebra is a language. It's a language of still adding, subtracting, multiplying, dividing. But that's what those letters, those variables do for us, all right? So let's take a look at some problems today and see how we can work with them and how we can move them around, manipulate them, all right? So first problem, let's see what we got going, guys. What have we got up there? It says if y equals mx plus b. Now some of you say, oh, that sounds familiar. What is that? That's slope-intercept form for you Algebra 1, and actually for you pre-algebra students, it's slope-intercept. It's how you graphed. You got y by itself. But this time what we'd like to do is figure out what is that variable b, the intercept work. Now let me go back through just a little bit here. I always like to notice when we use a formula, especially if formula is used as much as this will be in your math career, the m is the slope, the b is the intercept, all right? Hence, that's why we got slope-intercept. And by the way, it's specifically the y-intercept. That's why y is leading the way, all right, up here. So y by itself gives us a y-intercept if x should go to 0, all that good stuff. But you want to know, how do we solve for variable b? So write this one down at home, all right? Go ahead and put it there. We start with a y equals to our mx plus b. And what we need to do is figure out, how do we get b by itself? All right, what's keeping us from having b by itself? And it's this guy here, this mx, and it's a clump. It's, so to speak, it's a term. And that term, it looks like a clump. It's two numbers multiplied together. And what we need to do is subtract that whole thing over to the left-hand side. So we're going to subtract it from the right to remove it. But remember, if we subtract something from the right, we've got to subtract it from the left. And here's where we go. What have we got left over here? Now, some of you are going like, what are you going to do with those m's and x's and y's? We're not going to put them together in one clump. We're going to leave it as y minus the mx, and that will equal to our value b. That's where we're going. Now, again, you say, Ernie, you got 4 letters up there. What does that mean? It doesn't mean anything until I assign those 3 values. Then we can find the 4th value. All right? So again, remember, these variables are simply like a formula. They're holding for a number. They're waiting for us to put some values in. So we've got it. We've got this y is minus there, and that was an m. It just kind of had a little trouble. And there's that x. So we just put it in there, nice expression. I didn't say a term. Those are 2 terms, the y and the mx. But they're separated by that minus. It's very important. So now let's do the replacement on it. Let's put in 5 for y. You see, there it goes. Let's put in 3 for m. By the way, there's a minus hanging on there. We got to keep that in there. And let's put that -2 right in there. And you see, that's going to equal b. This is why we manipulate. It makes it very easy for us just to replace and maneuver our formulas very well. We're going to do a show on formulas later on this summer. There's a lot of different area formulas and volume formulas and things, perimeters. But for right now, we're just going to play with a few manipulating of variables. Sometimes the formulas make sense like this one. Sometimes they really don't. They just give us practice, all right? But let's see where we're going. We're going to take 5, and we're going to multiply first. Remember good old dear Aunt Sally? My dear old Aunt Sally? Or my dear Aunt Sally. I doubt put old Aunt Sally, bless her heart. Let's see. We've got a 3 times -2. And that is going to give us 5. We're going to subtract. What 3 times -2 is, my friends? That's a -6. and that equals to our b. Watch out. These two get jamming, all right? Go add the opposite, becomes plus a positive. Folks, the b value is equal to 11. Equals to 11. Now, could I check that real quick? I could plug it right back up here in the original formula, but that's why I substituted this way, was so I could isolate that variable b, and there it is. So it's simply for my arithmetic, and yes, we could go back and replace it, and we would see that you would end up with 5 equals, looks like a -6 plus 11, and it would give you that original value to be equal on both sides. So it does check. It's easy to check through. Those are kind of what we're looking at today, literal equations. Notice there were 4 variables in that one. And you know what? I bet every one of you handled it, all right? If you didn't, you knew how to now, right? You know how to do it now. Let's see where we're going to on this one, next one here. It says 4x plus 2y equals 4a minus 2y, and we're going to try to get y by itself. That's what's going on here. When we solve for a variable, that means that's going to be found by itself. This is a little more complex, so let's write it down and see what's going on. 4x plus your 2y equals 4a minus that 2y, okay? Now, first of all, some of you are out there thinking, I know you are, because I have students who do it too, and sometimes, probably, I did it once or twice or a few times in my lifetime also. You look at that 2y and that minus 2y, and you say, yay, they cancel out. But they're on opposite sides of the equals, so you can't let them cancel out there, all right? Now, if it were plus 2y, you'd be in business for that. And there again, we're trying to solve for y, so it can't disappear, or at least it's not supposed to, all right? So what we're going to have to do, we're going to have to add 2y to both sides, and this is where you got to be careful, all right? So add that 2y right over here, and it didn't disappear, did it, folks? Nope, it sure didn't. So we got 4x, we got 4y, and all that good stuff is equal to 4a. We did get it a little more put together, all right? Now keep in mind, our goal is to get this 4y and then y by itself. So let's move this 4x. We need to subtract 4x from both sides. And that is going to leave us with, let's put it out here, it's going to give us 4y by itself. And now I've got 4a minus 4x. Oh, we're getting closer. We're getting closer. What do we need to do now? Divide everything through by 4. We'll do just that. And you know what we end up with? We end up with y equals, wow, 4 divides into everything? We get a minus x. Wow, that is so much easier to look at. So much easier to look at. Now, here's our situation. We got the formula. You want to make sure? Everybody want to make sure? Let's go back and make sure. We have the 4a by itself because the y's have canceled at this point. Over here, however, the y's have grouped up and given us 4 of them. And we have 4x that comes straight down. Nothing's affected on the a's and the x's yet. Now, we subtract 4x from both sides. And again, it's tempting. There's a 4 on both of them, but you can't do anything except write it 4a minus the 4x. And the order is important, my friends, because the minus is on the 4x. It's on the 4x. So make sure it goes in there. Now, let's kick along here. We've got y equals a minus x. Let's bring it right back down here. This is an easy formula now, isn't it? My goodness, all I have to do is write what? 5 minus 2? No way. Is it that easy? It's that easy. Y equals 5, put in for a. X2 goes in. You got 3. How easy, how easy. And you can put those 3 numbers right back in there up in the top, and life will be pretty nice. Again, very, very easy little problem when you look at that. I mean, we could look at it all different levels here. From here to here to here, they all work out, So again, that's what happens. Folks, it's all about the variable standing for numbers. Once you get where you're going, then simply substitute some numbers in and you can get another answer. You can get another value. Let's take a look at this next one here. This one we're not going to ask to put any values in, but this is a little more advanced. My goodness, how many letters? There are 5, and nothing looks like it wants to combine. No like terms up here, that's for sure. So let's rewrite. So we got Km minus Pf equaling to x. This time we're out to look for what is K. So here's where we are. We're starting with everything moving except for the K. So you say, wow, Ernie, what are we going to do? Well, we've got a clump right here that needs to move. It's the furthest away from Km, and that clump is two numbers multiplied. We don't know what P and F are, but PF is just a product. But it's got a minus in front of it, so to move a minus situation, we add that clump, so to speak, that term, if you will. We add it to both sides. And we've got a little bit better situation. We've got K, M hanging on over there on the left side. These guys say goodbye. And the PF appears on the right. Again, keep it separated. It's X plus PF. X plus PF. Now notice how is our K and M related together? They're multiplied. They're a product, if you will. How do you undo a multiplication? You undo it by dividing. Now we want to be left with K, so the thing I need to divide by is M. The M needs to take care of itself. Right there, we're going to divide by the M. And you know what? You hear me say it before. If we divide on one side, we got to divide on the other. Good old division property of equality. By the way, that was the addition property up there when we added both sides. All right? So we're using these properties of equality that are all of a sudden becoming rather important because they allow us to do what we want to do. And we end up with this M by itself. And down in the bottom, we've got K now by itself on the left. All right? So you've got to remember that M's got to go in the right. Because we did it on the left, we must divide the right by that. So it does appear alone in the denominator. Now what's left on the left side? Left on the left side, I like that, it's pretty good. It gives us K. On the right side, it's not pretty, but remember what I said, until we put numbers in there, it's just a formula. It's just a formula. We aren't going to substitute on this one any values or numbers, but there you go. Situation accomplished, all right? So be sure you keep up with your steps. First thing first, we added because it was subtraction here. We divided here because we're undoing multiplication, and we have to divide over here. And that simply is with K. And if we knew what these numbers were, we might come up with a nice, simple, perhaps fractional expression, maybe an integer, maybe a whole number, maybe a mixed number, maybe an improper fraction, all sorts of things that could come out. Could even have zero. But nonetheless, there's your story, all right? So keep it with us there. Keep it with us there. Let's look at our next problem, and fairly easy little problem to solve out here. It says P equals A plus B plus C. This sounds like it could be a triangle. Actually, it could be a triangle. Shouldn't it be? Because we have three sides, we would add them together, and that could be a perimeter. It could also mean some other things, all right? It could be a sum of some things that are just adding three quantities. But I kind of like looking at that could be a formula for a perimeter of a triangle. Let's write it down here. P equals A plus B plus your C. And the situation here, dear friends, we want C by itself. What's keeping me from having C by itself? Well, I see an A, I see a B. And you know what? They're both connected by addition. So let's disconnect them, so to speak, by subtracting. Now if we subtract it on the right, we're going to have to subtract it on the left. Good old subtraction property of equality. So let's see what happens. Let's do one at a time, all right? So let's take A, let's subtract A both sides. And that's going to say goodbye to the A's. It's going to leave me with P minus A on the left, and I've got B plus C on the right. Which doesn't get us very excited, does it? Well, it doesn't get me excited anyway. We want C by itself. Let's get the B out of there. That will make me a little more excited because then I will have C by its lonesome, all right? Keep that minus A over there, all right? It's going to be good. Now, let's subtract B minus B. And things are getting rather hefty on the left, rather skimpy on the right, all right? So we've got P minus the A minus the B. And finally, we have C by itself. With B by itself. C by itself, sorry. Now, kick on along here. There's your formula. Let's put it up here. C equals P minus A minus B. Now, I know there's someone out there, I'm sure they are, because you all are good Mathline folks, all right, that is saying, Ernie, could we have added A plus B together first and then subtracted? Yes, we could. And let me show you how that would look. That would be C equals P minus, in parentheses, A plus B. We could have added those two numbers together and then subtracted it from that P value. So let's see what exactly happens. Let's use the formula here, and let's write it down here. We've got it C equals, I'm going to go back to what we had originally in terms of the formula, the first one we found, P minus A minus B, all right? And we're going to substitute. We have C equaling, we've got 35. And it says A and B are both equal to 14. That's not a misprint. That's simply saying they're both 14. So we're going to minus 14, and we're going to subtract another 14, all right? And it looks to me like some of you are thinking, oh, we could have gone like that, right? And added them and said 28 and then subtract. That's another way you can get there, all right? As it is, let's go ahead and figure it out. Let's figure it out. This gives me, it looks like, oh, how about it, folks? 21 minus 14. I'm going to work it left to right because that's what order of operations says to do. And then that will come out to give me 7. Now you say, Ernie, could we have added 14 and 14 gotten 28 and subtracted from 35? And yes, you would get 7. So either of these formulas works. Either of these representations is a good answer. It's a good answer, all right? So there you go, little variable manipulation, literal equations where we are today. Let's look at our next problem here. Kind of funky here. It says if 8x minus k equals 3y, let's solve for k. All right, watch closely, my friends. Watch closely. Let's see what we got. We're going to pick it up over here. We're going to say 8x minus k, that's what our problem says, equaling to 3y. Get you a chance to write it down there at home. And I'm going to go ahead and I'm going to subtract the 8x from both sides. Use a little subtraction property equality going on here. And I have this minus k, or negative 1k, or a negative k, however you want to look at it. Opposite of k is my favorite way of doing it because k could be negative. We never know. Equals your 3y minus 8x. Now, why am I saying pay close attention? Because we are going to, some of you say, oh, it's done. Well, that was easy. Not yet. All right? We got a negative 1 sitting in front of that k, and that negative 1 needs to get divided by. So we're going to do that. We're going to divide by negative 1 all the way through, and here's what's going to happen. It's going to become a positive k, but your signs are switching. Oh, watch closely. Yes, watch closely. Because we divide a negative into a positive, it goes negative. And we divide this negative into a negative, it goes positive. So we're going to have 8x minus 3y. Now you say, Ernie, could you have written negative 3y plus 8x? Yes, you could. Yes, you could, folks. It'd be fine. It would be fine. I wouldn't count you wrong. You may have a teacher that would, but I don't think there are many of them out there that would, all right? This is fine, as is negative 3y plus 8x. But let's go down here and figure out, will these numbers work together? What does that mean? So if we've got this original, not the original, let's go to what we've figured out. Let's see what k equals. K equals 8x minus 3y. So in other words, if you supply a 3 in for x, it'll be 8 times 3, and you supply a 9 in for y, the question is, will you get 3? That's our question mark. Now, I'm not saying that's a fact. Some of you are just tuning in on Mathline saying, my goodness, what's he saying? Is it going to work? That's the question. Remember, you multiply first. Do your multiplication. My dear Aunt Sally comes to rescue here. We got 3 equaling 8 times 3. Y'all got that one? How about it? 24. And we're going to subtract 27. Now, folks, that's a positive 3 there. This is not. Woohoo! In this situation, we are basically saying 3 equals negative 3, not. So guess what? Will it? No. Those 3 numbers do not work. And it's possible that if you forgot and messed up on the sign, you might have gotten them to work. All right? So you got to be careful. Got to be careful. That sign switches your signs in the right-hand side when you divide it by that negative 1. Very critical, very important. So as I said, big no to that question. Big no. They are not one and the same. Not going to work one and the same. All right? So, again, those are why we worry about how do we manipulate, how do we use our literal equations, how do we go back and then replace numbers. Let's take a look at this next one here. actually doesn't look very difficult at all. The catch is, folks, if you look at it, you've got an x on both sides. You've got an x on both sides, and you're going to try to solve for x in the equation. So you've got to get x by itself. So the first things we need to do is move the 3x over there so we can get an x, have a chance at getting x by itself. So let's see, we're going to subtract 3x right there. Y'all got it? Everybody's doing it right, okay? Going to subtract from both sides. We have, oh, this one really looks a lot easier than I thought it would be. You get 2x equaling p. Now, 2 times x. Y'all listen? You taking care on here? Thinking. Good. Let's divide by 2 because that's what we need to do. We can divide by 2 here, divide by 2 there, and our 2's are going to cancel out, and I'm left with, as some of you will call it, p over 2. That's the way I'd call it too. But it really means p divided by 2. So if p is some value, okay, let's say p is 6, then we divide p by 2 or 6 by 2, we get 3 for x. So it looks like in this case, x is always going to be half as much as our value p. Which brings me to another option. Some of you said, well, when we got to 2x equals p, could we have multiplied both sides by half? You most certainly could. And those halves and that 2 would cancel. You're left with x, and you're left with 1/2 of p. Either one of those is a good answer. Either one of those is a good answer, all right? So it works either way. So sometimes I like to show you there are answers that are necessarily, they're equivalent. They're okay, all right? And this one is that case where you could have had 1/2 of p, or you could have p divided by 2 for your final solve for x moment, all right? So that's how it works. How it works. Not hard out there, is it, folks? Think how you can get your variable by itself. Let's look at this next one here. Very much, actually a lot of similarity to this one, just a little bit more twisted. So we want a by itself. Unfortunately, we have an AT and, an AR. Didn't put a number in front of them, did we? It's not like we got 5A or a 6A, although you could think of T and R being different. So it means we're going to do something about that. We're going to have to subtract somewhere. So let's do this first. I see x's on both sides, and I think that opens the door. Let's subtract 3x first, okay? Let's subtract 3x from both sides. And what that does, that basically opens up AT on the left, and it gives me AR plus x, because remember, 4 times 3 gives us 1, so we just write it x on the right. That already takes a little bit of the pressure off. Now, what I've got to do is get a's together. So let's move this a over to the other side. That's going to give me a subtract moment. So we're going to subtract AR from both sides. And already I'm going like, this is exciting because I've got AT minus AR equals x. Now I can't make anything else but that, all right? Those are not like terms. They have to be connected in that manner. Oh, I've solved for x. Oh, it says we're going to solve for a. Well, you know, we got to figure out a way to get a by itself now. All right, so let's do a quick look at this. Notice there's an a in common to both of these. I'm going to bring up the thing called a GCF, greatest common factor. I see an a in both of these. I'm going to take the a to the outside and bring a parenthesis right underneath there, or right by it. Not going to be underneath yet. It's going there in a minute, though. We're going to have t, take the a out of both of them. We're left with t minus r equaling to x. Looking for a. Take a look at this before I hit the final moment. I want everybody to get a chance out there to look at this. We're going to divide. This is multiplication. A times this parenthesis. What's keeping me from having the a by itself? It's that parenthesis. It's hooked by multiplication. Let's divide. Let's divide it. You know, you do it to the left, you're going to have to do it to the right. And you know what? This cancels out. There's like, we could put a little parenthesis around that, so they cancel out. You're left with a equaling, I see x over, or x divided by, a quantity, t minus r. So if you're substituting numbers in here, you would need to do that subtraction before you divide it into that number left over there. But there's your final gig on that one, okay? A equals x divided by the quantity t minus r. So folks, we got a little bit of literal equations. We did get literal today, didn't we? Got a little physicalities up here. You know, we got some YouTube shows. In fact, this one probably will appear up on YouTube one of these days, very soon, hopefully. www.youtube.com/TNLearn. And other problems of the day are always there from the rest of the year. And a lot of our summer school episodes are going up there too. Of course, like us on Facebook. We love it when you like us on Facebook. There it is, www.facebook.com/TNLearn. And be sure to send us emails. Hey, thanks for tuning in. And you know what? We will see you tomorrow.